Welcome students for the 10th standard physics subject. Let us glance in a minute what are the chapters we covered in our previous class. In 9th standard we studied motion, sound, gravitational, force and resistance laws and work and energy. Since we are at home due to lockdown, open your old books, reread all the lessons which you already learned. If our basic knowledge is strong, then it will be useful to understand the new topics. And we know we are in 10th standard, we should take it as seriously, and we know that 10th board results are important for our decision making for the further admission process. So make sure you learn seriously and follow what and all guided given by the teachers. In 10th science, we have 16 chapters. Under that, these are the chapters comes under physics. So our first chapter will be electricity. Then magnetic effect of electric current, these both are in our textbook. Then light, reflection and refraction, the human height and colorful world, and the source of energy. And our last chapter is sustainable management of natural resources. This is continuation of 9th standard natural resources, and here we have the human height. In 9th standard we studied human here. So today we will start with electricity. We are not going directly to the subject, we will just discuss few introduction about electricity. In next class we will study the electricity chapter. So let us see. By looking at the name electricity, we come across so many inventions. For example, bulb, motors, and today nowadays electric cars and all running. There are many scientists who contributed in this field. Among all of them, the first person who will come in our mind, or the first person who we will recognize is Thomas Edison. Who is that? Thomas Edison. He is the first person who invented electric bulb in 1878. Since then, our places are brightened even after the sunset. So electricity plays an important role and convenient form of energy for various useful things. For example, we are using homes, schools, hospitals, industrial areas and research areas, etc. So we can't imagine the world without electricity. So now we will start what is actually electricity is. Well, electricity is basically in two forms. Electricity is basically in two forms. That is, the first one is static electricity. Static electricity. And the second one is dynamic electricity. Dynamic electricity. Static electricity is nothing but study of charge in rest. So, study of charge in rest. So, what about dynamic electricity? It is nothing but study of charge in motion. Study of charge. Study of charge in motion. So now here we got the word electric charge. So we will see what is electric charge now. Electric charge. There are two types of charges. We already know, that is positive and negative. And this electric charge, this concept is very important in physics. Let us consider magnet for a moment. We know that magnet, the two like poles are repel each other. That is, let us draw a drawing for a better understanding. So these are our magnets. South, north, south. See, two like poles always repel each other and two unlike poles always attract each other. Similarly, in our charge, plus and plus will always repel. Same, negative and negative will always repel, and plus and negative will always attract each other. This is an important parameter which we should not forget in electric charge. Now we know electric charges are plus and minus. Now we will see who carries these charges. So the question is, who carries these charges? These charges are carried by tiny particles called as subatomic particles. Subatomic particles. So familiar with the word? Yes, we studied this in 9th standard chemistry chapter, this structure of an atom. We studied what is suborganic particles and all. So no need to go in depth. I'll directly come to the point. Our positive charge is carried by a particle called as protons, and negative charge is carried by a particle called as what? Electrons. Electrons is also written as like this. So recall yourself, who discovered protons and electrons? Electrons were discovered by J.J. Thomson and protons were discovered by Goldstein. So this is a basic parameters which we need to study. So remember all these things. Let us consider an object. Let it be metal. In metal, electrons can move randomly wherever they want. But in non-metals, electrons can't move freely because they have a fixed position. So electrons will move in metal wherever they want. Suppose electrons will move in one direction in wire. For example, this is our wire. Electrons will move in one direction. So what is this wire? This wire is nothing but metals. So we know what are the properties of metals and non-metals. Metals are good conductor of electricity. So what is conductor now? Conductor is nothing but which allows electrons move from one particle to another particle. So now what about insulators? Insulators are which do not allow electrons to move from one particle to another particle. So here we learn, what are the things we learn? We learn what is, again, there are two types of electricity. What are they? Two forms of electricity. Static electricity and dynamic electricity. Later on we studied subatomic particle, that is with protons and electrons. So these are some basic concepts which we need to remember to start our main topic, that is electricity or current electricity. What is electricity? Electricity is the flow of charges through cross section of conductor. And we studied in last class what is charges and conductor, right? And this electricity is basically in two forms, that is static electricity and dynamic electricity. Static electricity is nothing but study of charges at rest, and dynamic electricity is study of charge at motion, that is moving electric charge. The example for static electricity is rubbing a balloon on your head. Just go back to your earlier previous classes. We did all these experiments, combing our hair or rubbing balloon on our head. What happens when we rub balloon on our head? The hair attracts to the balloon, right? That is due to friction. Now what is friction? Friction is a force which holds back the movement of sliding object. Now example for dynamic electricity is the electric circuits or the charge in bulb. Here we are mainly studying about dynamic electricity. It is also called as current electricity. And in the last class we learned about charges, right? What is charge? See, whenever a matter is placed in electromagnetic field, it experiences a force called charges. Charges is defined as internal property of any particle exerts electric force on another particle. So no need to remember the definition of charge, just we need to remember the properties of charges. Electric charge is nothing but internal property of any particle exerts electric force on another particle. A few properties of charges we learnt in our last class. What are they? That is, like charges repel each other and unlike charges attract each other. Properties of charge. I won't write everything on board, just listen. The first property what we studied in earlier class is like charges repel each other and unlike charges attract. Alright, like charges repel and unlike charges attract. Second property is charge is conserved. This means in an closed system or in an isolated system, the charge remains same. It won't change. And charge is represented with Q. It may be capital Q or small q. And SI unit of charge is coulomb. It is represented as capital C. Don't forget, we need to remember SI units. This is important in physics. And the smallest value for any charge is, the smallest value of any charge is given as 1.6 into 10 to the power minus 19. Remember this number, 1.6 into 10 to the power 19. And there is one mathematical formula for charge, that is Q is equal to N into E. We know Q is charge, N is number of charge, and E is any charge on the electron, that is 1.6 into 10 to the power minus 19. For example, if we have one electron can be written as 1 into, what is the value of, smallest value of any charge, 1 and 6 into 10 to the power minus 19. For 2 electron, we will write same as it is. It will be 2 into 1.6 into 10 to the power minus 19. Now, we will show that 1 coulomb has 6.25 into 10 to the power plus 18 electrons. See, all we need to show is 1 coulomb has these many electrons. How to show that? We can show that through some mathematical forms. We know now the equation or the formula for charge is, that is Q is equal to N into E, right? That is 1 coulomb, 1 N is number of electron that we need to do 6.25 into 10 to the power 18, right, as it is. E is what? Smallest value of charge, that is 1.6 into 10 to the power minus 19. Now N is equal to 1 divided by 1.6 into 10 to the power minus 19. 1 divided by 1.6 will become as 0.625. Calculate that one. And what happens is, when this comes to numerator from denominator, will become positive, that is 10 to the power plus 19. Now we will shift 1 0. If we shift this point, we will get 6.25 into 10 to the power 18 electron. If they ask us to prove or show that, use this formula and do it. If not, usually they will ask what is the value of 1 coulomb. All you need to write this number, 6.25 into 10 to the power 18 electron. Now we will see what is current. Electric current. See, electric current is indicated by the symbol capital I, and it is defined as rate of flow of electric charge. Rate of flow of electric charge. Definition is almost similar to electricity. And SI unit of electric charge is, sorry, SI unit of electric current. SI unit of electric current is ampere. denoted by the symbol capital A, and it is named after the French scientist, that is André-Marie Ampere. So here, as I said earlier, SI units are important. Electric current is denoted by I and its SI unit is A. Now we will see the mathematical formula for current. Current, that is ruled by the symbol I is equal to charge. Charge by time. This is the mathematical formula, that is I is equal to Q by T. So what is SI unit for current? C is equal to SI unit of current is ampere. Ampere is equal to coulomb and SI unit of time is seconds. This is our formula and this is related to SI units. Now we know the formula and we need to learn one point here. Current can also be expressed in milliampere and microampere. So what is milliampere? Milliampere. 1 milliampere, that is milli can be written as small m is equal to milliampere. The value of milli is 1 into 10 to the power minus 3 ampere. And what about micro? 1 micro ampere can be written as 1 into 1 micro ampere, the symbol 1 micro ampere is equal to 1 into 10 to the power minus 6 ampere. They may ask you for 1 mark, so remember the symbol as well as the number. And here I have one important point in current, that is conventionally in an electric circuit the direction of current will be always opposite to the direction of flow of charges. See, this is our conductor A to B. If electrons flow in this direction means the current will flow in opposite direction. So you need to remember, in an electric circuit the flow of current will be opposite to the flow of electrons. So whatever we learned under current is definition, its SI unit and formula, and it is expressed in micro and milliampere. Our next topic is electric potential difference. This is one of the important topic we need to understand, and we need to remember the definition with formula. Electric potential, electric potential difference. Let me explain with some experiment. Imagine we have two beakers. We have two beakers, both of them filled with equal amount of water. Both of them filled with equal amount of water, and they are connected with pipe at bottom. Now observe here that it is beaker 1 and beaker 2. Observe here, is there any flow of water from beaker 1 to beaker 2 or beaker 2 to beaker 1? No, there is no flow of water here. So what makes to flow the water from one beaker to another? We need to raise height of any one of the beaker, right? So here height is a fact to flow water from one beaker to another beaker, right? In the same way, if you make beaker 2, raise the height, the water will flow from beaker 2 to beaker 1. So height is the fact. In the same way, for the flow of electricity, there should be one fact, and that fact is potential difference. Now look at the word potential. We will come across potential energy and kinetic energy. Potential energy and hold the ball in our hand, or else I have a duster in my hand, this has potential energy. Potential energy defined as stored energy of an object when it is at rest. If I drop this duster, the potential energy will convert into kinetic energy when it reaches the ground. That means kinetic energy is defined as object having energy when it is at motion. Similarly, the potential difference of any charge describes how much stored energy it has. Hence, potential difference, electric potential difference is defined as the amount of work done to move a unit charge from one point to another. See here, we came across the word work done. About this we learned in our previous classes. So go back and learn what is work done, what is its SI unit and all. Hence, it is defined as the amount of work done to move a unit charge from one point to another. Potential difference is denoted by V only. The SI unit of potential difference is voltage. SI unit is volt, and the mathematical formula for the potential difference is potential difference is equal to work done by charge. Work done by charge. That is 1 V is equal to W by Q. You see this? We need to solve numerical problems. What is 1 volt is equal to SI unit of work done is joules and charge is coulomb. 1 volt can be defined as 1 joules per coulomb. This is mathematical formula. Now, related to potential difference and electric current, we will solve few problems. Look at our first question. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through circuit. Always first write down the given things. Given ampere. If it is in ampere, this is current. I is equal to 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Time is equal to 10 minutes. See, always convert minutes into seconds. That is 10 into 60 will become 600 seconds. Find the amount of electric charge that flows through circuit. We need to find out charge. That is Q is equal to question mark. Now look at the given things. Which formula we can use here? The current formula. That is I is equal to Q by T. Then we can remodify this formula as Q is equal to I into T. Substitute the values in formula. You will get I is equal to what? 0.5 into 600, and our answer will become 300. What is the SI unit of Q, that is charge? It is coulomb. Hence, coulomb is our unit, and answer is 300 coulombs. And now, look at our second problem. How much work is done? We need to find out work is done in moving a charge of 2 coulomb. They are given charge across 2 points having potential difference 12 volts. Here, in given things we have work done in different of charge. They are given 2 coulomb and potential difference, that is V is equal to 12 volt. And our formula is V is equal to work done by charge. We need to find out W, and formula will become W into W equals V into Q. Substitute the values. That is 12 into 2. We get 24. What is the unit of work done? That is joules. See, in in problems always will have half a mark for unit. So always write unit with correct answers. Mainly in today's class we learned about electric current and potential difference, and we solved related problems.